हेलो फ्रेंड्स, क्या आपने इसी चैनल पर न्यूक्लियर केमिस्ट्री के जो पहले वाले वीडियो अवेलेबल है वो देखकर स्टडी की है? अगर नहीं की तो जल्दी से जल्दी मेरे स्वप्नाली एस जादव चैनल को विज़िट कीजिए और उन वीडियो को देख लीजिए और आने वाले सभी वीडियो को देखने के लिए मेरी चैनल को सब्सक्राइब कीजिए। ओके, तो आज हम इस वीडियो में देखने वाले हैं पॉइंट फ्रॉम न्यूक्लियर केमिस्ट्री, दैट इज़ न्यूक्लियर फ्यूजन। Nuclear fusion. So what is mean by nuclear fusion? Definition: a nuclear reaction in which two or more isotopes of very light elements fuse with one another to form stable heavier nucleus with liberation of large amount of energy is known as nuclear fusion. ओके, देखो डेफिनेशन क्या है। A nuclear reaction in which two or more isotopes इससे पहले वाले वीडियो में मैंने isotopes मीन्स क्या होता है वो समझा है। सो प्लीज़ टेल मी व्हाट इज़ मीन बाय isotopes में क्या सेम होता है? एटॉमिक नंबर सेम होता है या मास नंबर सेम होता है? सो इन isotopes having same atomic number but different mass number are known as the isotopes. So tell me the isotopes of hydrogen, which are that? H11 hydrogen, H12 deuterium and H13 that is tritium. Okay, these are the isotopes of hydrogen. So what is the definition of nuclear fusion? A nuclear reaction in which two or more isotopes of very light element fuse with one another to form stable heavier nucleus with liberation of large amount of energy is known as nuclear fusion reaction. Okay, so we see one example, that is for example when H12 means which one? Deuterium fuse with H13 that is tritium, then there is formation of stable heavier nucleus that is He24 helium nucleus with emission of one neutron and liberation of 17.6 million electron volt energy. Okay, this is the example. Deuterium when fused with tritium, then there is formation of helium nuclei with emission of neutron and with liberation of 17.6 million electron volt energy. Okay, in fusion reaction whatever energy we get is approximately 4 times greater than fission reaction. Approximately 4 times greater than which reaction? Fission, nuclear fusion reaction. But one condition is necessary. Which condition? That is for fusion reaction very high temperature and high pressure is required. High pressure is required. 4 times greater energy मिल सकते हैं than fission, but condition is what? For nuclear fusion reaction, very high temperature and very high pressure is required. So how much temperature required? That is about 4 into 10 raised to 6 degrees Celsius. 4 into 10 raised to 6 degree Celsius. So for conducting fusion reaction, such a range of high temperature required. Hence, nuclear fusion reaction is known as thermonuclear reaction. Therefore, high temperature is required. Therefore, nuclear fusion reactions are known as the thermonuclear reaction. Remember that. Okay. Thus, the principle of fusion reaction is used in hydrogen bomb. In nuclear fusion reaction, we studied 2 cycles. That is proton cycle and carbon nitrogen cycle. Proton cycle and carbon nitrogen cycle. Let us see first, that is proton cycle. So proton cycle was given by scientist Bethe. Which scientist was given? Bethe. So according to him, the energy of sun appears to be generated by proton cycle, where temperature is about 2 into 10 raised to 7 Kelvin, because for fusion reaction high temperature is required. So energy of sun appears to be generated by proton cycle, where temperature is about 2 into 10 raised to 7 Kelvin. So how this cycle is appeared? So here proton cycle. So starting material proton. So when proton combines or fuse with another proton, then there is formation of H12, that is deuterium, plus emission of positron with liberation of energy 0.42 million electron volt, and this reaction happened 2 times, therefore into 2. Okay, then what happened? Another proton is fused with that deuterium, and there is formation of He23 plus with liberation of 5.50 million electron volt. This is also 2 times. Okay, then what happened? That 2 He23 plus He23, they form helium nuclei He24 plus 2 proton H2H11 plus liberation of 12.80 million electron volt energy. Okay, so overall reaction is here. What happened? H12 cancel, that 2 He23 cancel. Here how many protons? 2 plus 2. Here 2 into 2 4, 2 means 6, but here how many liberate? 2 protons are liberated, so they also cancelled. From here 6, remember how many proton? 4 proton, 4H11, it gives He24 plus positron. How many positron? Into 2. Therefore 2 positron plus, and overall this energy how many becomes? 24.64 million इलेक्ट्रॉन वोल्ट. तो देखो यहाँ क्या होता है, H11 plus H11 it gives H12 with emission of positron plus energy. Then that another proton combines with H12, then there is formation of He23. That 2 He23 forms He24 with liberation of 2 proton and energy. So overall यहाँ क्या होता है, on LHS how many protons are present? 6 proton, and on RHS 2 protons. So 6 minus 2, there are 4 proton, gives 1 helium nucleus with emission of 2 positron and large amount of energy, that is 24.64 million electron volt of energy. Thus here net result is conversion of 4 protons to 1 helium nucleus with emission of how many energy? 24.64 million electron volt energy in the form of heat and light from the sun per cycle. There is so many such cycle is continued, and we get heat and light from such which is liberated during reaction. Okay, I hope आपको ये प्रोटॉन साइकिल समझ में आया होगा, और हमको जो सन से जो हीट एंड लाइट मिलती है वो किस रिएक्शन से मिलती है, ये आपको अच्छे से समझ में आया होगा. चलो अब हम स्टार्ट करते हैं नेक्स्ट साइकिल, दैट इज कार्बन नाइट्रोजन साइकिल. कार्बन नाइट्रोजन साइकिल was proposed by scientist Bethe and C.F.von Weizsacker. Bethe and C.F.von Weizsacker. Okay, so according to him, to produce solar energy of very hot star having temperature about 5 into 10 raised to 8 Kelvin. Okay, 5 into 10 raised to 8 Kelvin. This cycle produce carbon nitrogen cycle to produce solar energy of very hot star having temperature 5 into 10 raised to 8 Kelvin, which can be represented. So here what happened? Carbon. So carbon 612 when fused with proton, then there is formation of nitrogen 713, which is radioactive with liberation of 1.94 million electron volt. This is radioactive, means this is unstable, so it emits positron or electron. So here mass number is higher than usual mass number या lower than usual mass number? That is lower, therefore it emits positron. So here for carbon 613 plus positron with liberation of 1.20 million electron volt energy. Then what happen? This carbon 613 combines with proton, then there is formation of nitrogen 714 plus 7.55 million electron volt energy. Then next, that nitrogen 714 combines with proton, and there is formation of oxygen 815, which is also unstable with liberation of 7.29 million electron volt energy. Next, that oxygen 815 is unstable and having lower mass number than usual mass number, therefore it emits what? Positron. And here for nitrogen C.F.von with liberation of 1.74 million electron volt, and at last this nitrogen C.F.von when combines with proton, then there is formation of carbon 612 plus He24 plus 4.96 million electron volt. So see, when carbon 612 plus H11, there is formation of nitrogen C.F.13 which is unstable. It emits positron and form product carbon 613 which combines with another proton and formation of nitrogen C.F.14 which combines with another proton and forms unstable oxygen 815 which emits positron and form nitrogen C.F.15 which combines with another one proton and form carbon 612 with one helium nucleus and energy. So overall reaction here, carbon 612, carbon 612, nitrogen 713, nitrogen 713, carbon 613, carbon 6. These are cancelled. These get cancelled. Okay. So what remain? What remain here? H11, 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 H11 means how many proton? 4 protons forms. Here remaining He24, one helium nucleus, positron 2 positron with liberation of this energy. How many total energy? 24.68 million electron volt. Okay, thus here net result is conversion of 4 hydrogen nuclei into one helium nucleus with emission of 24.68 million electron volt energy, okay, per cycle. But for completion of single cycle, how much temperature required? 2 into 10 raised to 7 degrees Celsius and 6 million years are required. 6 million years are required. Therefore, such reactions are not suitable for man-made experimentation. Okay, understand? Thus, the principle of nuclear fusion reaction is used in hydrogen bomb. Okay. आई होप आपको ये न्यूक्लियर फ्यूजन पॉइंट समझ में आया होगा। अगर आपको ये वीडियो पसंद हो तो लाइक कीजिए, आपके फ्रेंड्स को भी शेयर कीजिए, और अगर अभी तक माय चैनल को सब्सक्राइब नहीं किया तो सब्सक्राइब कीजिए। फिर मिलेंगे इन नेक्स्ट वीडियो लेकर न्यू पॉइंट, दैट इज़ न्यूक्लियर फ्यूजन रिएक्शन। ओके, बाय, थैंक यू वेरी मच फॉर वॉचिंग माय वीडियो।